Alright, so this is our winch project. We're basically trying to create a machine, a winch that will convert electrical energy to mechanical energy. And basically the goal of this is we have a system here, and this is our machine, and it's connected to a power supply. The power supply is going to attach to a breadboard, which attaches to a motor, and it's going to lower a 1 kilogram weight through our winch. So we'll demonstrate that right now, I guess.
Yeah.
So this is the 1 kilogram weight that Jonathan's going to put on a paper clip. And now when you click our button, it'll slowly lower the 1 kilogram weight. And if you see, if we increase the voltage, the weight will go faster up until then. So, yeah.
It only went 15 centimeters. We marked it.
We marked it, yeah.
We marked it.
So, just to explain to you a little bit about the data that we collected. So, the first weight, Jonathan will tell you a little bit about the data of the first weight.
The first weight, as we told you, was the 1,000 gram.
No, it's first.
The 500. No, this one.
This one's 1,000, yeah.
Yeah.
So we used two. So the first one that Jonathan's talking about,
Is the 500 gram, which converts to 4.9 newtons, and the second one was the 1,000 grams that we just showed you, and that converts to 9.8 newtons.
Yeah.
The length that we measured it at was 15 centimeters, which is 0.05 meters. And then, so for the work, do you want to do that?
Yeah. So the voltage we had for both weights we used 7.2 volts, and we had when we tested it, the current was all the way up on the power supply, but when we tested both the weights, it used a current of 0.24 amps. And so for our work, for the larger mass, our work was, for the smaller mass, sorry, for the 500 gram mass, we got 0.735 newton meters for the work, and for the larger mass, the 1 kilogram, we got 1.47 newton meters for the work.
And then after that, we did the
Joules, yeah, that's what we meant.
And then for the power out, we took the of what we found for the the work, and then we divided it by the time it took, and then we got for the first one was 0.0816, and for the second one it was 1.47 work, and then we divided that by the time it took, which was a little longer, which is 9.5, and we got 0.1547. So there's a little bit more because there was more friction from the bigger weight. Then for the power in, we did the amount of the current, which was 0.24. We multiplied it by 7.2, which was the voltage that we used, and for the first one we got 1.728 watts. And then for the second one we did the same thing, and we also got 1.728 watts because it was the same voltage and the same amount of current. Yep. And for the third one we measured the efficiency. So we just took the power out and divided it by the power in, and then multiplied it by 100. So for the first one we got 4.7, and that was with the smaller weight. And then for the second one we got 8.9, which was bigger, and it's understandable because that was a bigger weight.
So you have more efficiency for what's long?
Oh, sorry.
Yeah, so we got more efficiency for a larger mass, and it usually, you wouldn't think that, but what our philosophy was, since we have a larger mass, and since we're lowering it, the mass of the object plays a portion in lowering it itself due to gravity. So we're saying that although it's powered by the motor to let it go down, the mass is still going to have a little bit of effect on the rate at which it's going down due to gravity.
What about on the way up?
On the way up, if we test it on the way up, it should in fact be the opposite. The efficiency for the larger mass should be less than the efficiency of the smaller mass.
Okay, good.
Yeah. And then for our conclusions, we listed different examples of how we can reduce efficiency in the winch system, and one of them was friction. because we had a lot of friction between the gears and the string and also with the axle. So if we like made that a lot better, we could have had a lot less friction. And the weight, as we said, if we used less weight or a lighter weight, we could have reduced a lot more of the time that it took instead. So that would help us out there with reducing the efficiency.
Yeah.
Or to reduce efficiency.
So one strategy that we could use to make it more efficient was definitely reducing the friction. So using gear oil, maybe using little different materials, and making sure that you can see like a lot of our screws and a lot of our nuts are tightened all the way to the brackets, and that's what's basically causing a lot of friction. So just doing little things like that that are going to reduce the overall friction of the system is a big portion of why this is so inefficient. And two reasons why automotive engineers are concerned with eliminating inefficiency from vehicles. So nowadays, due to pollution and stuff like that, automotive engineers want to basically reduce, make sure vehicles are the most fuel efficient, and make sure that we're not polluting the atmosphere and whatnot. So that's why they want to make it most efficient, so they don't have to use as much gasoline, as much fossil fuels, reduce the overall pollution, and conserve energy. Okay.
Great, thank you very much.
Thank you.
Can we do some welding?
Yeah, Mr. D.